All right. Welcome to episode 3 of the Cinci Data Fabric Learning Series. Today, we're going to be covering off autonomous data, how to create and manage data without adding specific data silos.
So we talked previously about how data itself is useless. It's intelligence that people are after. Intelligence is actually the new oil, not data. And the concept of plasticity is a prerequisite for intelligence. And if you just look at the human brain as an example, our brains manage more data than the biggest company on the planet. As we learn, our brain reorganizes. That's neuroplasticity. And that continues right up until the end of our lives. And people with higher IQs actually have more efficient neural networks. There are fewer connections between that data. So that plasticity is a key requirement to enabling advancement in intelligence. And the emergence of data fabric technology is what makes structural plasticity actually possible in an enterprise context, whereas traditionally that is not possible. You have rigid data models sitting inside of rigid databases where data is fragmented, and depending on the size of the organization, you have a handful, you have dozens, you have hundreds, some have thousands, some even have tens of thousands. So this new technology is really breaking through that barrier and enabling that plasticity, which itself enables intelligence, but doesn't alone guarantee that intelligence. But in the last session, we showed you what our data fabric looked like in September 2018, so 2 years back, and what it looked like last week. Where you can see the result of that plasticity evolving over time and the resulting intelligence that gave us as an organization, which is similar to what our customers get. So today we're going to be talking about the idea of autonomy and autonomous data. So in the same way that plasticity is a requirement for enabling intelligence, autonomy is a prerequisite for enabling evolution, which is key if you want to grow that intelligence over time. So the way to think of it, if you want to become the intelligent organization, you really need both. You need the plasticity and you need the autonomy. So the old way of thinking is the idea of a collective. There's a single brain, you're data driven, where basically people, machines are agents of the central brain. If you ever watch Star Trek, the Borg is a perfect example of that. That's kind of the conventional thinking, but that is definitely not the way forward. The way forward is through the concept of collaborative intelligence. And I'm not sure if I mentioned this in the last session, but these concepts are not unique to our technology. We're creating the software equivalent of these, but these are concepts that exist in the real world that you can do some research on. And it's actually really interesting if you find this interesting. But collaborative intelligence is really a better way where you still have agents, but people have autonomy. People, machines, they have their own person level intelligence, but they're connected through a common fabric, a network where they can solve problems together and grow their individual intelligence while retaining that autonomy, which is a much better way. So you can look at the enterprise as an example. It's powered by autonomy, and there's many examples of that. If you look at how we do documents, how we work on, how we message each other, how we meet, how we deliver projects, and now how we collectively evolve our intelligence. So the idea of autonomy is critically important, and it always wins. If you ever watch Star Trek, Starfleet always beat the Borg. Borg never wins. The collective never wins. So autonomy is key. The architecture approach, just another quick recap here, is traditionally you have applications that you either buy or build. Each has a UI, API, logic controls, persistence. It's missing the plasticity, and of course it has integration, which consumes half the budget. With the introduction of the data fabric, with the plasticity layer on top of that, it opens up a couple of new usage patterns. Last week, we covered the idea of augmenting applications, basically taking existing applications, making them more intelligent by connecting them to the fabric and then enabling this plasticity. But there is the second pattern, which is to leverage the idea of autonomous data to make it so that when you're building new experiences, you don't have to build the controls and persistence that you would if you were following a traditional application-centric build approach. And then in future sessions, we'll start to introduce the idea of the metadata experience. It's not a data-driven experience, it's the metadata-driven experience, where really it's an automated experience creation for humans or for machines that reacts to the ever-evolving metadata. So we'll cover that in the future session. So today, it's all about autonomous data. What does that actually mean? And I'll give a demo and show how it works, and it should be good fun. But before I actually go forward, I'm just going to pause. Does anyone have any questions on any of the concepts from past sessions or anything that we've covered so far before we jump into the idea of autonomy and autonomous data?
Hey, Dan, this is Shweb.
Yep.
So previous episodes links, do you know where I can find? Is it on?
Yeah, if you go to cinchi.com/learn, it has the prior episodes, and so we've set this up as a weekly series. So if you're not able to, it's great if you can join live. If not, you're welcome to watch them online after the fact. Usually we have them posted within 24 hours.
Awesome. Thank you. I found those. Thank you so much.
All right. So the idea of autonomous and autonomy is a fairly commonly understood word, but it's the ability to be self-governing, to control one's own destiny, and you know, it's a pretty important concept in society, and it's a pretty important concept in data and enabling intelligence. And so when people hear, you know, technology and the word autonomous, you may think of like autonomous driving, autonomous vehicles. Now that is definitely autonomous, but it's very different than what we're talking about here. Autonomous vehicles are really about taking the control away from the human driver and handing it over to the software. Because as a human driver, you may just want to be able to do other things, like this guy having a nap. But of course, you still want to be able to take control at some point. But autonomous doesn't necessarily mean taking control away from the people and handing it over to the software. It could actually go in reverse. No autonomous data does not enable Skynet and self-awareness and all that good stuff. So autonomy is definitely a good thing when applied in the right context. But today, it's the applications that we have that run our organization that control our data. We don't control it. So if you decompose an application, what is it actually comprised of? Well, you've got code. That code ultimately limits your experience. You can only use the features of functionality that are exposed to you. And if you want new features and functionalities, you have to change the code. And that code is rigid, it's brittle, it's not data, it's not dynamic. So that limits your usability and accessibility, which is a problem at every company on the planet. The code itself then owns really the database that results in the fragmentation and duplication of data. So the database is really there to serve the code. It's not an independent thing. It is there. It's a subservient to the code. Within the database, you have a model, a schema, basically tables and columns and metadata, and that is really there to serve the needs again of ultimately the code. The code is the recipient of this. It's the owner of this. It's the boss of the model. It's purpose built, and these models traditionally don't enable plasticity. They don't enable schema evolution. You go and rename a column, it's going to break your code. You drop a table, you add a table. It's very rigid. It's very brittle. Now, within that model, you have your actual data. That's a pretty important asset. But you can see it's buried kind of deep into the inner layer here. And because of all these layers that get in the way and add all these challenges, data is hard to access. It's impossible to control at scale. And this is everything that we're showing here is in the context of just a single application. When you zoom out of one app and look across apps, the problems are magnified. It's exponential, these challenges, which is why, as an example, integration consumes half of the budget of every company. For those of you familiar with microservices, which are the evolution of service-oriented architecture, which is a great way to enable code reuse, unfortunately, microservices doesn't help with this problem. It doesn't help bring the data to the center. So a microservice at the end of the day is still code, and that code needs to save information, and it's going to use a database, and that database is going to have a model, and that model is going to be where your data is stored. So it's the same fundamental pattern. So microservices definitely solve problems of code reuse and breaking down monolithic applications and code bases and all that good stuff, but it doesn't solve the idea of enabling autonomy, data autonomy. It's just really a smaller version of a larger application. So if we look at a hypothetical project, so how do we put all this into action? So what this is showing is hypothetical project where we have two legacy applications. This could be maybe a SaaS platform. This could be an on-prem platform. And we're, in this scenario, augmenting an existing application. So this would be a third legacy application, but we're augmenting it. This is what we covered in the last session of how you can add UI capabilities, how you can add API capabilities and add logic against your existing application in the language and technologies that you want. You're not using the platform to really help with that. What you're doing though is you're avoiding the having to implement additional controls and additional persistence and additional data that is trapped inside of a model and make changes to that. Sorry about that. And what you're using instead is the fabric and the plasticity that it ultimately enables to act as the middle and back end of your augmented application. So that's the first thing. Of course, the metadata experience we'll cover in future sessions. But today, really, it's the back end of the idea of an application experience where you have a UI, API, and logic, but that is a net new, what otherwise would have been a standalone bespoke application, but there is no data store, there is no data silo, there is no app-specific controls or anything. It's born free. It is autonomous data that exists solely on the fabric, and that's what we're going to cover today. So I'm gonna flip over and now show you some examples of what that actually looks like in practice. But again, before I do that, I'm just gonna pause and see if anyone has any thoughts, comments, questions. I'm curious, have any of you heard of these concepts before around autonomous data? Is this new to everyone that's on the call today?
New for me.
Okay.
Yes, agree. New.
Okay. All right. So we're back in the platform. And if you remember in last week's session, we augmented, in that scenario, we extended Salesforce with new capabilities as well as untrap that data by connecting it to the fabric. But again, this is our own data fabric that we actually use to run the company. So this is all of our real data. Now, in the scenario of our company, we actually run pretty much everything as autonomous data. And we only connect in other sources really for demonstration purposes, because frankly, a lot of our customers have a lot of existing systems and they're not going to throw this away. They're going to want to extend and augment and connect them. So for us, it's predominantly autonomous data. So what that really means is that if you think of the need to manage some new data to support some new business process or enable some new business capability, often your thought process, as soon as you move beyond kind of high-level requirements to design, is, well, which application am I going to change to capture this new data? And if there's a substantial amount of new data, meaning let's say it's a new product, a new market, a new something that's materially new, where it's not just new attributes, it's new entities, you may consider buying or building a new application for that, which itself will follow that conventional pattern of code that uses a database, that uses a data model that manages the data on your behalf. And your layer is, your view into that is limited to the functionality. Whereas with autonomous data, you don't have to think about that so much. You can essentially just create the structure, essentially build the semantic model, and not necessarily have to map it to which system it's coming from, because maybe it's coming from the fabric itself. So what I'm going to do is I'm going to create a couple of sample structures and show you a little bit about how the access controls manage. And today we'll predominantly focus on enabling users to interact with autonomous data. And then in future sessions, we'll show how you can enable machines to interact with that autonomous data through a number of protocols. So you can see for myself, I have 147 objects that I have bookmarked, of which 90 of them are tables. And I also have some queries and experiences that I have bookmarked, but I'm going to actually create an entirely new table. So a table is a data set. It's tabular, it's rows, columns. So anyone familiar with traditional kind of relational concepts, this is going to be very familiar to you, but at the same time, it's simplified and doesn't have the limitations of a relational data store. Now, in this scenario, I'm going to do this one from scratch. You can, of course, import, and you can do what I'm about to show you. You can do that programmatically and through other automation, but I'm going to do it all through the interface today. And let's say we want to track a list of customers. So I'm going to create some really simple data structures here, but you should be able to extrapolate and apply it to obviously more complex structures. So let's say we have our customers. I'm going to pick a domain. A domain is a container that you organize, and it really is a container for not only organization, but also for governance. And in our environment, I've created a domain called Sandbox that we use for doing demonstrations. I'm going to give it an icon. Let's say we want it to be purple users, and I'm going to give it a description. Normally I'd be a little bit more descriptive, but I'm sure you have better things to do than watch me type. So that's really the macro structure. The next thing I'm going to do is I'm going to describe the columns of this table. So I'm going to add a column. So let's say we want their first name. I'm going to choose the data type. In this case, I'm going to leave this as text. For the description, I'm not going to bother to fill this out for the others, but I'll just put one here. Of course, this one's self-explanatory. You don't really need it, but I'm going to choose the data classification, and these are actually managed in a separate table that as an organization you can control. It comes preloaded with the default where you have confidential, internal, public, and restricted. But of course, those are customizable depending on your organization's information security policies and procedures. So let's say in this scenario, it is confidential. I'm going to go to advanced, and I'm going to say that this particular field is mandatory. I'm going to skip over some of the other capabilities here. I'm going to add another field called last name, and I'm going to say that is also confidential. I'm not going to bother with the description. I'll make this one mandatory as well. Let's say we have birthday, that's going to be a date, that's going to be confidential. And let's say we have net worth. So that's going to be a number. I'm going to say that that is confidential, and I'm going to format that as a currency, and I'm going to leave that one as optional. And I'm going to go ahead and save this data set. So what I've actually done is I've created a very simple table with just 4 columns. So think of it as it's an empty structure. There's no data in it, and only me as the creator have any ability to interact with this data, including to be able to actually add rows of data through the UI. But by default, creating the structure doesn't give anyone access to even know that the structure exists. So one of the first things that you're going to do is you're going to go to Design Controls. And this is where you're going to give access to either people or machines. And today we're going to focus on giving access to people. So let's say that I want to give access to Joanne. So I'm going to add a grant, and of course this would integrate with single sign-on and Active Directory and other such integrations for identity and access management. I can also do systems here. I can do groups, but I'm going to keep it simple and just give Joanne direct access to that. And now I'm going to configure the level of access. So I can choose whether or not Joanne can discover it through the built-in marketplace to enable discovery of this as a data set, whether I want to prevent or enable her to do bulk exports, prevent or enable her from doing direct queries, like literally running SQL queries against it, whether I'm going to allow her to design the table as a builder, similar to what I just did, design access controls, which is what I'm doing right here, right now, whether she can view all the data or view selective columns. So let's say I'm going to allow her to see these 3 fields, but not the net worth. I can then restrict or enable her ability to edit 1 or more data cells. So let's say that she can edit the birthday, but not the first name or last name. I can also optionally turn on change approvals, where we can segregate who can change versus who can add versus who can delete, where any such change needs to be approved before it officially takes effect. I'm not going to do that now. We'll cover that in a future session. I can restrict whether she can add, whether she can delete, and I can also optionally apply filters to the individual rows on what can be viewed versus what can be edited. So for example, I could add a constraint here on the editable row that says she can only edit the birthday if the last name is her last name. So what she would then see is she would be able to discover the data set. She would be able to do a bulk export, but she's only going to see 3 out of the 4 columns because she's not going to see net worth. And the birthday would only be editable in the event that the person that she's looking at is in fact herself. So she can self-manage her birthday in that scenario. So that's the idea of providing entitlements. Now, that's it. It's literally, it takes effect instantly. So Joanne could literally log in and start to use this access right here, right now. But let's go back into managing data. So the data set, of course, is empty. So I'm going to just add a couple of sample rows. And I'm, again, going to do that just through the user interface. So let's just say we have, let me start with the birthday, because if you remember, we put first name and last name as mandatory fields. So I'm just going to say that the birthday was September 1st. And notice that there's 2 validation errors. First name is required, last name is required, and the birthday can't be solved until those 2 requirements are satisfied. So let's say we've got Bob. So now there's only 1 error left, and we'll say Smith. So now that record is saved, and I can also populate a net worth and go ahead and make that change. Now, all data on the fabric that is autonomous benefits from some very common control capabilities. So first of all, you already saw a little bit of that in terms of the ability to control access down to a data cell level. But there's more to it than that. If I make changes here, so let's say Bob Smith, and let me zoom in to make sure you can see it okay. So let's say Bob Smith becomes Bob Jones. So I've made that change, but all the changes are tracked in a central collaboration log for every row, regardless if the schema changes, like the data model. I can rename this column, I can do all kinds of other changes that would typically break things, and it's not going to break it here. And the collaboration log, you can see it shows every change. So it shows that I, Dan, created this record September 24th at 11:55. Then I populated the net worth, and then I changed the last name from Smith to Jones. Well, if I want to roll it back from Jones to Smith, I could obviously just update it, or I could just go and revert it back. And now we're back to where we were before. But if I check again the collaboration log, you can see it didn't actually go back to version 2. It went forward to version 4, but version 4 is the same as version 2, so that you have integrity in the log. Now, if I connect data from another system, like a Salesforce or a mainframe, I'm going to benefit from the same versioning here. As soon as the data is on the fabric, I'm getting essentially that automatic cell level data version control, where you can see who changed what when and be able to roll that back. Let me add a second row here. So I'll say we've got Jane, ABC, and I won't bother. Actually, I'll just fill those down. If I now delete Jane, Jane is gone, but it's actually in the recycle bin. So any data that is deleted, be it deleted through the UI, through an API, or if it's connected data from another source, can actually be recovered as simple as through a single click. So 1-click restore, and now that record is back. And if I check the collaboration log, you can see that Jane was created, changed, deleted, and then restored all over the course of under a minute. There's of course the ability to alter the view here. I can create personalized views, customized views that apply different filters, sorts, change the different columns. I can do that on the fly, where you can see I can rearrange if I want last name before first name, or if I want to add in when it was created, who created it, who modified it, when it was modified, what the version of the record is. I can add those into the view, and you can see that that is dynamic. And in spite of the fact that there's data in the structure, I can actually go into design mode and alter the schema. So I can start to rename things. So maybe I just want F name and L name. I wouldn't recommend this because you can't have spaces, so that's a bad name, but I'm going to do it anyways because it won't matter, because it won't break things, including anything that has a dependency on this. But I'm going to add one more field here, and I'm going to create a link, because while we added net worth, what we didn't do is specify what currency that's in. So I'm going to add a currency. Now I happen to know there's a built-in discovery mechanism, but I happen to already know that there's a currencies data set that's already on the fabric that I have at least read access to, so I can connect to that and point to it. So I'm going to link it to the currency code, and I'm going to connect it based on, let's say, the ISO name for that particular currency, and I'll say that that is internal. And I'll leave it at the end there, and I'll just go ahead and save that. So now I've extended the schema, I've altered to, and I've added another field where I can now go back and populate this. So if I want to do the Canadian dollar, and this one I want to do the US dollar, you can see that's an actual link. So if I were to click through that, it's bringing me to that associated record, and I can go back to our customers. If I were to change that in spite of it being a link, I'll just pick one randomly here. Of course, if I go to the collaboration log, I'm seeing the original changes, including the two that I just made, where I populated the new field called currency, as well as then changed that currency. And you can see there's F name and L name, which were renamed. So there's really a lot of built-in controls that through the built-in interface that allow the data to be managed without it having to exist inside of a siloed application where you have to create a custom UI to be able to simply manage that data. Now, in future sessions, we'll cover the idea of the metadata experience, which will go beyond what you're seeing here in terms of the ability to interact with that data. We'll cover connectors. We'll cover really all the other missing pieces of the puzzle and how it all fits together. But the idea here is that I'm extending existing entities with new attributes and adding new entities without having to add an app for that and a silo for that. Any questions, comments?
Actually, I got one, Dan. I understand the model. So I'm just trying to conceptually think of, is the model part of the underlying data tables, or does it poll to get refreshes? Like how would an update in an underlying data table get populated to Sinchi? So
in this scenario, like when I make this change, keep in mind Sinchi is a persistent store. So under the covers, it's managing that such that, like, if I just change that and press enter, the transaction is committed and it's persisted to disk somewhere in the kind of the magic beans behind the software. Now, in the scenario where that particular data is not autonomous, meaning it's connected, well, that's what the connectors kick in, where it can push that back to whatever the source system is. It's either a source or a destination, depending on what you're doing. And that could be real time, it could be near real time, it could be batch. There's different frequencies depending on the connector. But in the scenario of autonomous data, that's what the platform is doing, is it's managing that persistence. And your question around the metadata itself, we're going to cover this actually in the next session, the idea of active metadata. But that's a very powerful concept. But the way to think of it just really quickly is this is kind of an illusion. There's a table called our customers and a column called LNAME, and there's a row that has an ID of 5, which is the second row here with a value of L. But these are not as they may seem. Sure. The actual table itself is actually a row of data in another table. The metadata is all data. So next week, we're going to go deep into that. And we're going to show how, first of all, how Sinchi works kind of under the covers a little bit. But then we're going to show you what kind of things you can do with that active metadata, which is pretty powerful in terms of helping you evolve the evolution of your fabric over time. And things like dynamic glossaries and catalogs, like all those things are just built in. Think of it as autopilot governance.
Cool. Okay, thanks.
Okay, so I know we're actually a few minutes over. Next week we're going to be covering active metadata, so hope to see you all there. And if you're unable to make it, don't forget the recordings are all available on the website. This one will be there within 24 hours. And please, if you're getting value from these sessions, share with others. And if you're interested in connecting to see a live demonstration or just learn more about data fabric technology or any of the concepts that we're talking about here, just reach out to Sinchi.com, and we'd love to connect. Joanne, is there anything else that you wanted to add before we close?
That's exactly the close I was going to do. So thanks very much. Sign up for episode 4 and make sure you share these out with the rest of your network.
Perfect. Thank you so much. Have a good day.
Thank you,
Thanks, everyone.
Thank you.